So in my last video I discussed about the working principle of pantograph when raise command is executed by the train, or can say when we provide raising command with the help of TCMS to the pantograph to get raised, then how entire circuitry works. I have discussed about that in my last video. So in this video I am going to talk about working principle of pantograph when ORD or can say MED operates. Now you must have been thinking, what is ORD and MED? ORD, MED both are same things but having two different names. If you would consider the logic behind the name, then you will easily understand what is ORD and MED. ORD, overreach detection device; MED, maximum extension device, right? So imagine the situation in which train has gone to the non-OHE zone from OHE zone. So in such cases what will happen? Height of the pantograph will get raised than its normal height. So we need to bring down the pantograph to the lower position, because height of the pantograph has reached to the certain limit, has reached more than the certain limit. So we need to bring down the pantograph to prevent the pantograph against any major damage. So in such cases MED, maximum extension device, or can say ORD, overreach detection device, operates, due to which pantograph comes down to its lower position. Here one thing that we need to understand, pantograph is coming down to its lower position. So in such cases we need to control the speed of pantograph as well, and this lowering is known as normal lowering. The reason behind why this lowering is known for normal lowering, the reason being there is no damage which is caused over the pantograph and its components. So that's the reason this lowering is known as normal lowering, right? So we can conclude one point: when MED operates, then pantograph will come down, and in such cases speed of pantograph will also get controlled. Pantograph is not coming down by gravitational force, which happens in case of ADD, automatic drop down device. Now automatic drop down device, about this device I am going to make video in my upcoming video. I am going to cover this topic in my upcoming video. Now what is ADD, automatic drop down device? Imagine the situation: due to some catenary issues, pantograph strip has got broken down, due to which what will happen? Due to which air will starts to drain from the carbon strip of pantograph, and pantograph is broken. So in such cases ADD, automatic drop down device, will operate and pantograph will come down. In such case lowering speed of pantograph cannot be controlled, and pantograph will come down due to gravitational force, and this lowering is known as abnormal lowering. So we can we can make the conclusion from both of these devices: if pantograph comes down by the gravitational force, then that lowering is known as abnormal lowering, which happens in case of ADD, and rest of the lowering is normal lowering. Like in case of MED, normal lowering, because pantograph is coming down, and the lowering speed of pantograph is also getting controlled with the help of valve, with the help of there is one device about which we are going to discuss in this video itself, right? So we'll understand first of all with the help of this circuitry. Once this circuitry will get complete, once we'll get the complete idea about this circuitry, then we'll discuss about theoretical approach, right? So we can see here it is the complete panto control circuit, right? As I have discussed in my last video, in PCU, panto control unit, there is an optimum pressure of 7 bar which will raise pantograph, right? If pressure is less than 7 bar, then pantograph cannot be raised, but if pressure is more than 7 bar, then obviously pantograph can be raised. That 7 bar optimum pressure, it is coming from here, right? It is coming from here. I have discussed in my last video, right? This filter will filter the pneumatic pressure, and then that pressure will go in solenoid valve 1, due to which solenoid valve 1 will get activated with the help of TCMS, and then the pneumatic pressure will go in pressure regulating valve. Pressure regulating valve convert that incoming pressure into working pressure. Working pressure is responsible to maintain static contact force. Now what is static contact force? Again I am discussing about it in a very simple way. Static contact force is a force which is responsible to keep the carbon strip in continuous contact of OHE, and if I talk about its magnitude, it is 70 Newton. Why Newton? It is force, right? Now then we have pressure gauge. This pressure gauge will show the magnitude of working pressure, right? And then we have throttle raising valve 1. This valve controls the speed of pantograph, raising speed of pantograph, right? And then that pneumatic pressure will go in air bellow drive, due to which air bellow drive will get filled, and then that pneumatic pressure will flow from here. Under normal condition I am speaking, insulating hose 2, and then that pneumatic pressure will go in pressure switch 1, due to which pressure switch 1 will get activated. Now this pressure switch is getting activated, so what will happen? Electrical pulse will generate, and that electrical pulse is responsible to show us status of pantograph, that pantograph has been raised finally and pantograph is in contact with OHE. So we'll get to know about it with the help of electrical signal via TCMS. Okay. Here we need to come to the term with the fact that there are two valves which has been used here, quick exhaust valve and wave valve 1. Now wave valve 1, WVM1, this is wave valve 1, and QEV1 means quick exhaust valve. Quick exhaust valve is associated with ADD, automatic drop down device, and then this wave valve 1 is associated with overreach detection device, or can say MED, right? Now under normal condition both of this valve remain deactivated. Now what is normal condition? Normal condition is condition in which neither ADD is operating and neither MED is operating, right? So this condition is known as normal condition, right? So in normal condition both of this valve remain deactivated, but in case, imagine the situation in which train has gone to the non-OHE zone from OHE zone, due to which height of the pantograph will get raised than its normal height, due to which what will happen? In such cases wave valve 1 is activated. Now once this wave valve 1 is activated, then pneumatic pressure flows from this wave valve 1 as well, right? Now that pneumatic pressure flows from insulating hose 3 in this way, insulating hose 3, and then that pneumatic pressure will go in pressure switch 2, and then that pneumatic pressure will go in wave valve 2, right? Now this pressure switch 2 is not activated, right? Once this wave valve 2 is activated, then this pressure switch 2 will get activated, right? So in this way pressure will flow, pneumatic pressure will go in insulating hose 3, and then it will go in pressure switch 2, and then that pneumatic pressure will go in wave valve 2. Once this wave valve 2 is activated, then this pressure switch 2 will get activated. Now this pressure switch 2 is activated, so what will happen? Once this pressure switch 2 is activated, then two things will happen. First of all, electrical signal will generate, and this electrical signal will show that MED is activated, or can say electrical signal will generate, that electrical signal will indicate that MED is operated. Once MED is operated, then pantograph will come to its lower position. So when pantograph is coming down to its lower position, then in such cases we need to control the speed of pantograph, lowering speed of pantograph. So lowering speed of pantograph is getting controlled with the help of throttle valve 2, right? Now another thing which will happen when this pressure switch 2 is activated, our solenoid valve 1 will get de-energized. So this solenoid valve 1, once it get de-energized, then the pneumatic pressure, how it will get de-energized? It will get de-energized with the help of TCMS, right? So once it will get de-energized, then the incoming pressure which is coming in panto control unit will get blocked, right? And one more thing which we need to understand, once overreach detection device is activated, then air which is there in air bellow drive will get drained out, due to which air will get exhaust, air will get drain out, and pantograph will come to the lower position, and lowering speed of pantograph will get controlled with the help of throttle valve 2. Here there is this one more valve, throttle valve 1. So what is the purpose of this throttle valve 1? Now again this throttle valve 1, under normal condition when pantograph is coming down, then lowering speed of pantograph is being controlled with the help of throttle valve 1. So whatever we have discussed, so let's do quick revision of that. When pantograph exceeds the normal height, then wave valve 1 gets activated. जैसे कि हमने डिस्कस किया, जब पैंटोग्राफ अपनी नॉर्मल हाइट को क्रॉस कर लेता है, नॉर्मल हाइट से ज़्यादा हो जाती है पैंटोग्राफ की हाइट, तो ऐसे केस में जो वेव वाल्व 1 है वो क्या हो जाता है? एक्टिवेट हो जाता है। और जो न्यूमेटिक प्रेशर है वो वेव वाल्व 1 से होते हुए इंसुलेटिंग हॉर्स 3 से होते हुए वेव वाल्व 2 में जाता है, जिसकी वजह से जो वेव वाल्व 2 है वो क्या हो जाता है? एक्टिवेट हो जाता है। जैसे ही वेव वाल्व 2 एक्टिवेट हो जाएगा तो ऐसे केस में जो प्रेशर स्विच 2 है वो क्या हो जाएगा? वो एक्टिवेट हो जाएगा। प्रेशर स्विच एक्टिवेट हो जाएगा, जिसके वजह से होगा कि इलेक्ट्रिकल सिग्नल जनरेट होगा पल्स के फॉर्म में, और वो जो इलेक्ट्रिकल सिग्नल होगा वो एमडी या फिर जो ओआरडी है उसे क्या कर देगा? एक्टिवेट कर देगा, जिसकी वजह से हमें पता चल जाएगा कि ओआरडी या फिर जो एमईडी है वो क्या हो गया? वह एक्टिवेट हो गया है। जैसे ही एमईडी एक्टिवेट हो जाएगा तो ऐसे केस में होगा कि जो एयर बेलो ड्राइव के अंदर जो एयर है वो क्या हो जाएंगी? ड्रेन हो जाएंगी, जिसके वजह से होगा कि हमारा जो पैंटोग्राफ होगा वो नीचे की तरफ आ जाएगा, और जो पैंटोग्राफ की जो लोअरिंग स्पीड होगी उसे कैसा कंट्रोल किया जाएगा? उसकी जो लोअरिंग स्पीड होगी उसे कंट्रोल किया जाएगा थ्रॉटल वाल्व 2 के थ्रू। राइट। और जैसे ही हमारा प्रेशर स्विच 2 एक्टिवेट हो जाता है, जैसे कि हमने डिस्कस किया, तो ऐसे केस में इलेक्ट्रिकल पल्स जनरेट होगा और वो जो इलेक्ट्रिकल पल्स है वो सोलेनॉइड वाल्व को भी क्या कर देगा, डी एनर्जाइज करवा देगा टीसीएमएस के थ्रू। टीसीएमएस सोलेनॉइड वाल्व को डी एनर्जाइज करवा देगा, जिसकी वजह से पेंटो कंट्रोल यूनिट में जो इनकमिंग एयर आ रही है वो क्या हो जाएंगी, वो ब्लॉक हो जाएंगी। राइट। तो जैसे कि हमने डिस्कस किया था जो पेंटोग्राफ, नाउ पेंटोग्राफ विल कम डाउन एंड लोअरिंग स्पीड ऑफ पेंटोग्राफ इज कंट्रोल बाय थ्रॉटल वाल्व टू। दिस लोअरिंग इज नोन एज नॉर्मल लोअरिंग। राइट। जैसे कि हमने ये जो वाल्व के बारे में जो डिस्कस किया था, जस्ट गिव मी सेकंड, जैसे कि हमने जो थ्रॉटल वाल्व 2 के बारे में डिस्कस किया, जो पेंटोग्राफ की जो लोअरिंग स्पीड होगी इन केस ऑफ एमईडी ऑपरेशन, वो लोअरिंग स्पीड को थ्रॉटल वाल्व 2 क्या करेगा, कंट्रोल करेगा। और ये थ्रॉटल वाल्व 1 के बारे में हमने डिस्कस किया था, जब नॉर्मल कंडीशन में हमारा पेंटोग्राफ नीचे आएगा तो थ्रॉटल वाल्व 1 क्या करेगा, पेंटोग्राफ की लोअरिंग स्पीड को कंट्रोल करेगा। राइट। फिर उसके बाद अगर हम लोग देखें, सिग्नल ऑफ PS2 ऑल्सो डीएक्टिवेट सोलोनाइड वाल्व 1 विद द हेल्प ऑफ TCMS। राइट। जिसके वजह से होगा क्या, जो PCU में जो इनकमिंग एयर है वो क्या होगी, वो ब्लॉक हो जाएंगी। अभी यहाँ पर जब MED ऑपरेट हो जाता है तो इसके बाद हमें क्या करना होता है, जो नॉर्मल ऑपरेशन होता है उसे हमें क्या करना होता है, रीएक्टिवेट करना होता है। राइट। तो ऐसे केस में टू रीएक्टिवेट और टू रीस्टोर नॉर्मल ऑपरेशन ऑफ पेंटोग्राफ, पुश बटन, एक पुश बटन दिया होता है वेव वाल्व 2 पर, उसे हमें क्या करना होता है, मैन्युअली पुश करना होता है। राइट। और साथ ही साथ जो सोलोनाइड वाल्व है उसे भी हमें क्या करना होता है, उसे हमें नॉर्मल पोजीशन में एक्टिवेट करना होता है। सो हियर इट इज़ वन ऑफ द इंपॉर्टेंट थिंग दैट वी नीड टू कंसिडर इन ऑर्डर टू रिस्टोर द नॉर्मल ऑपरेशन ऑफ पेंटोग्राफ। वी नीड टू प्रेस द पुश बटन विच इज लोकेटेड ऑन वेव वाल्व 2, and apart from that we need to like reset the solenoid valve as well. We need to reactivate the solenoid valve as well in order to restore normal operation of pantograph. Right. तो यहाँ पर जैसे कि हमने डिस्कस किया है, यहाँ पर ये ORD और MED लोअरिंग, तो इसमें मेन इंपॉर्टेंट पॉइंट क्या है, इट इज़ नॉर्मल लोअरिंग। नॉर्मल लोअरिंग, वाई इट इज़ नॉर्मल लोअरिंग, बिकॉज देर इज नो डैमेज कॉज टू द पेंटोग्राफ एंड नीदर पेंटोग्राफ इज कमिंग डाउन बाय द ग्रेविटेशनल फोर्स, एंड दैट्स द रीजन this lowering is known as normal lowering. Lowering speed of pantograph is also getting control, so that's the reason this lowering is normal lowering. Lowering speed of pantograph is controlled by throttle valve 2. Right. Now pressure switch 2 is activated and turn off solenoid valve 1 to block airflow. यहाँ पे हमें एक चीज़ नोट डाउन करना होगा, ORD या फिर MED लोअरिंग में प्रेशर स्विच 2 काम करता है, ADD लोअरिंग में प्रेशर स्विच 1 काम करता है। राइट। अभी यहाँ पर ये दोनों जो प्रेशर स्विच है, प्रेशर स्विच 1, ये प्रेशर स्विच 1 और ये प्रेशर स्विच 2, दोनों काम क्या करेंगे, दोनों एक कॉमन काम करने वाले दोनों केसेस में। सोलेनॉइड वाल्व को क्या करेंगे, डीएक्टिवेट कर देंगे, जिसकी वजह से जो PCU में जो इनकमिंग एयर आ रही है वो क्या हो जाएंगी, ब्लॉक हो जाएंगी। साथ ही साथ यहाँ पर ये जो प्रेशर स्विच 2 है ये इलेक्ट्रिकल सिग्नल जनरेट करेगा और ये जो इलेक्ट्रिकल सिग्नल है वो इंडिकेट करेगा कि जो हमारा जो MED है वो ऑपरेट हो गया है। साथ ही साथ हमारा ये जो प्रेशर स्विच 1 है ये भी इलेक्ट्रिकल सिग्नल जनरेट करेगा, जो कि हमें ये शो करेगा कि हमारा जो ADD है वो क्या हो गया, ऑपरेट हो गया। और ADD में होता क्या, जो पेंटोग्राफ है वो नीचे आ जाता है और लोअरिंग स्पीड भी कंट्रोल नहीं होती, और पेंटोग्राफ जब नीचे आता है तो ग्रेविटेशनल फोर्स के वजह से नीचे आता है। राइट। और ADD लोअरिंग जब होती है तो इसका मतलब पेंटोग्राफ पूरा मतलब डैमेज हो चुका है, उसकी कार्बन स्ट्रिप टूट चुकी है। तो ऐसे केस में जो पेंटोग्राफ जब नीचे आता है तो इसे एबनॉर्मल लोअरिंग भी बोला जाता है। So that's it for this video. In my next video, I'll be discussing about ADD lowering due to ADD.